Hello students, welcome to my YouTube channel. How are you? I hope you will be fine. Today we are going to continue our topic according to atomic structure. Last time we discussed about ionization energy, but we were discussing actually electrons in an atom. In other words, we can say the electronic configuration. Electronic configuration was being judged by ionization energy. How ionization energy proves electronic configuration? This is our today's main concern that was left in previous class. We are going to study about, first of all, I will remind you what is ionization energy. Ionization energy, as we have discussed, is actually the amount of energy required to remove an electron from the outermost shell of an atom in its gaseous state. Let's suppose we have an atom of hydrogen which contains single electron. This single electron can be removed by giving the atom energy 1310 joule per Kelvin energy. Similarly, helium has 2 electrons, so there will be 2 ionization energies for helium. That this would be the first ionization energy, which is 2370. This would be its second ionization energy. As the number of electrons get more and more, so the number of ionization energies also increase. If an atom have 3 electrons in the surrounding of nucleus, then it would have 3 ionization energies. If an atom have 4 electrons like beryllium, it would have 4 ionization energies with first ionization energy, second ionization energy, third and fourth. Similarly, sodium has 11 proton number, so it would have 11 electrons. So it will have 11 ionization energies. But how we can guess the electronic arrangement in the outer shell or in the shells of the atom around the nucleus? This can be judged by the energy difference between the ionization energies of successive loss of electron. For example, sodium have 494 first ionization energy. It means this energy is less, so this electron can easily be removed. Can be removed by providing 494 kilojoule per mole energy. Similarly, these 8 electrons in the second shell will require more energy than the first energy. It means there would be a large gap between the energies of ionization for the first and second. Let us check. This is 400 and this is 4000 560. This is almost 4000 Kelvin, joule per Kelvin difference. Similarly, when this third electron is removed from the second shell, so it will have greater ionization energy. Similarly, for fourth, six, five, six, 7, 8, 9, 10, then there is a great difference between these two successive ionization energies. This is 20,000 and this is 141,000. Almost 113,000 difference. As the second shell electrons have lost, now we have to remove the electron from the innermost shell, that is first shell. Electrons removal from first shell would be very difficult. So this energy gap, this large energy gap between the successive ionization energies shows that electrons are arranged in different energy orbitals. And these different energy orbitals require different energy to remove the electron from their vacancies. Now, from all this discussion, what conclusion would be? This energy gap difference predict or confirm the simple electronic configuration of element. Predict or confirm simple electronic configuration. Okay, it means arrangement of electrons in the shells or orbits, you can say. Then it confirms the number of electrons in the outer shell. What other prediction? Confirm the number of electrons in the outer shell. Okay. As you have seen the arrangement of electrons in the shell like this, electronic configuration can be stated as in the subshell. What are subshells? Subshells actually Bohr atomic model explain the concept of shells. These shells contain the electrons according to the formula 2n square. This 2n square formula describes the electron in the orbit or shell. These orbits are further divided into subshells or suborbits, which are for the first shell, it have shell number 1, n is equal to 1, only one subshell, that is 1s. For subshell 2, shell number 2 is subdivided into two subshells, that is 2s and 2p. Okay. Then shell number 3 is subdivided into three subshells, 3s, 3p, and 3d. Similarly, fourth shell is divided into four subshells, that is 4s, 4p, 5s, 4d, 4f. This is the arrangement of subshell on the basis of their increase in energy. It means first subshell 1s would be at lowest energy, then 2s and 2p that are belonging to group shell number 2 are at second and third position in energy order, then 3s, 3p, then 4s. 4s has come earlier than 3d. Okay, 3d is at higher energy level than 4s. Similarly, 5s is at lower energy level than 4d. As S has spherical shape and only one orbital, that is why it has less energy and more stability. It means every shell is further subdivided into subshells. These subshells are further divided into degenerate energy levels, which are called orbitals. What are they? They are called orbitals. Orbitals, as we have discussed there, what are the orbitals? S, P, D, and F. These are orbitals. S orbital may contain 2 electrons only. P may contain 6, D contain 10, and F contain 14 electrons. So, our next concern about the orbital is their shape. How the orbitals are in their shape. Shape of the orbital can be discussed as on the basis of their size and structure. As one thing more, S I am to tell, S means sharp, P means principal, D means diffused, F means fundamental. Okay. Orbitals are the space or volume where the chances of finding an electron are maximum, that is up to 95%. Okay. Volume of space in which maximum chances of finding of electron. Now we are going to discuss the shapes of the orbitals. As we have discussed 4 different types of orbitals, that is S has spherical shape and is drawn as like this, like a spherical ball, sphere. P has hourglass with 2 lobes, like this. There are 3 types of p orbitals: px, py, and pz. X, Y, and Z. How the filling of electron is done in electronic configuration. There is a specific sequence of filling of electron for the electronic configuration of an element. Let's suppose, first of all, low energy orbit is filled, then in orbit there is further, as we have discussed, orbitals. These orbitals are filled on the basis of their energy level. S is lower energy level. S is at lower energy level. Then P is at lower energy level. Then D. Then F. First of all, S will be filled in shell number 1. Then S will be filled in shell number 2, that is 2S. Then 2P, P will be filled in, then S will be filled in third shell, like this: 1S, 2S, 2P, 3S, 3P. After 3P, we will move toward 4S. As We already have discussed 4s. S is at lower energy level than 3D, so 4s will be filled earlier than 3D. After 3D, 4p will be filled, then 5s, which we are not discussing anymore. Later on in our next lesson, we will discuss about our electronic configuration of some elements and their exceptions. But up till now, what we have learned, on the basis of which we are going to solve a practice question on the past paper. Question is right on the screen. The fifth to eighth ionization energies of three elements in third period. Which period is this? This is third period elements ionization energies table. The symbol are not actual symbol X, Y, and Z. Question 1 is state and explain the group number of element Y. What we have to note here, we are going to note the big energy difference, a large energy gap between the ionization energies. Which ionization energy pair have large ionization energy gap? Let us see. Fifth ionization energy is not much smaller than sixth. Similarly, sixth is not much smaller than seventh, and eighth is almost 3 times greater than seventh, which means this element belongs to seventh group, group number 7. Explanation. What would be the explanation? As there is large energy gap between seventh and eighth ionization energy. Okay. State and explain the general trend in the first ionization energies across the period. Third period. As we are moving in the period of the product table, shell number is not increasing. Shell remains same. Remain same. So no shielding effect. Okay. Number 1. Nuclear charge is increasing. Ionization energy will also increase. Did you get the points? Ionization energy will increase as we move from left to right in a period. Due to the increase in the nuclear charge, which causes greater attraction between the electron and the protons of the nucleus. Second thing, as there is no outer shell is adding up, so the shielding effect will remain constant. Ionization energy will not be affected by the shielding effect. Complete the electronic configuration of element X. Question part 3. What is element X group number? As we have discussed, they all are belonging to period 3. Period 3 means third period will have on 3 shells. This has X has large energy gap between 6th and 7th ionization energies. It means this belongs to group number 6. Group number 6, period number 4. Group 6, period 3. Period number is already given in the question. Then what would be the electronic configuration? 2s2, 2p6, 3s2, 3p4. This is the electronic configuration of element X. Hope you will get the point on the topic. If you have any query, please leave the comment below. Thank you very much.